this video, we're going to be looking at applications involving powers and roots. And unfortunately, I don't have my mic for this, so hopefully the sound won't be too bad. Let's go ahead and get started. So it says applications of powers. If A and B are the lengths of the legs of a right triangle, and C is the length of the hypotenuse, then A squared plus B squared equals C squared. This is the Pythagorean Theorem. And so basically these are our legs. The longest side is the hypotenuse. It's also opposite the right angle. And so let's go ahead and get started. On number 1, it says find the missing length in this right triangle. Give an exact answer and an approximation to 3 decimal places. So when we say an exact answer, that means we're going to give it in radical form. As soon as you give an answer to a certain number of decimal places, you're actually rounding, and your answer is no longer exact. All right, so let's go ahead and get started. So in this problem, again, Pythagorean theorem is a squared plus b squared equals c squared. You can see that we don't have c, but we do have the 2 legs. Let's call the 8 a and b the 10. And you can see it doesn't really matter if we change the order of these 2 terms. We know when we can add in any order. So it really doesn't matter which leg you call a and which one you call b. So let's go ahead and plug these numbers in. We get 8 squared plus 10 squared equals c squared. We can do the math here. We get 64 plus 100 is equal to c squared. So 164 is equal to c squared. Let's take the square root of both sides. Now when we do that, we normally take plus or minus, but keep in mind we're dealing with lengths here, and so with these types of problems, we won't be concerned with negatives because lengths can't be negative. So we're going to end up getting the square root of 164. Now, I look at that number and I'm thinking, there's a good chance I can simplify that. Remember, if we have a perfect square factor, then this radical is not considered simplified. In other words, if 164 is divisible by any of our perfect squares, then the radical is not simplified. Well, you can see that 4 is a likely factor here. In fact, if you divide by 4, you find that 4 times 41 is 164. And of course, 41 doesn't have any perfect square factors, and so this is going to be just 2 times the square root of 41. In decimal form, to 3 decimal places, you should get 12.806. Since they didn't give us any units of measure, we won't give an answer with units of measure. All right, let's move on to number 2. It says find the missing length in this right triangle, give an exact answer and an approximation to 3 decimal places. So here we need to find A, which is one of our legs. So I'm going to go ahead and, again, I'll write down Pythagorean theorem. C is 9. Remember, the longest side is our hypotenuse, and so that means the 7 would be B. So let's plug our numbers in. We get a squared plus 7 squared equals 9 squared. Let's square the 7 and the 9. We get a squared plus 49 equals 81. And let's go ahead and subtract 49 on both sides. We get a squared is 32. And let's take the square root of both sides. Again, I don't really need that plus or minus because length, it's always going to be positive, so we'll disregard the negative answer. Square root is 32, though. Again, I'm thinking this is not simplified. If you look at our perfect square factor, certainly 4 is a factor, but even bigger than that, you can see 16 would be the biggest perfect square factor. Now, if you did 4, you'd have the square root of 4 times the square root of 8. The problem is 8 is also divisible by 4, another perfect square factor, and so this radical here is not simplified. And so we have to go with the bigger perfect square factor, which in this case is the 16. Square root of 16 times square root of 2, we get 4 square roots of 2. And if you write that in radical form, the easiest way to do it is just take the square root of 32. You get 5.657. All right, now on number 3, I'd like you to try reading it and see if you can draw a picture. And not surprisingly, you'll get a right triangle in the process. But see if you can draw the picture and maybe even solve the whole thing. But this is really just an application of what we just did. All right, so let's see how you did. I'm going to draw my pole. And so this guy wire, it's a wire, is attached to the top of the pole somewhere. And it goes to the ground. And it's 19 feet high and 8 feet from the base of the pole. This would be the base of the pole. And so that distance there is 8. And so we have this right triangle, and we're looking for x, which is the distance or the length of this guy wire. And so we'll use Pythagorean Theorem again. A squared plus b squared is c squared. Let's choose a to be 8 and b to be 19. So we'll plug those numbers in. We get 8 squared plus 19 squared is c squared. So we're going to have 64 plus 361 is equal to c squared. And so finally we have 425 is equal to c squared. Of course, we'll take the square root of both sides, and we get the square root of 425. Once again, I'm looking at that 25. I'm thinking, I think that divides into 425. And in fact, it does 17 times. You can write this as the square root of 25 times the square root of 17. We get 5 square roots of 17. And in this case, we're dealing with meters. So our final answer is 5 square root of 17, or 20.616 meters. The numerical answer, 20.616, is more meaningful to us because we don't really know what is the number 5 times square root of 17. What is that number? So in this case, the decimal form makes more sense. Okay, let's move on to number 4. Applications of roots. So it says here, the diagonal of a square has a length 7 square roots of 2. Find the length of a side of the square. So let's draw a square, and the diagonal is 7 square roots of 2. Now you can see there's actually 2 triangles here. I'm going to go ahead and work with the lower one here, and I'm going to call my side x, and since it's a square, each side has the same length. And so you can see this is our triangle right here. And so we're going to use Pythagorean Theorem. In this case, a and b are both x, so we'll have x squared plus x squared is our hypotenuse squared, or 7 square roots of 2 squared. So x squared plus x squared is 2x squared. On the right side, we're going to multiply 2 of those 7 square roots of 2. So notice we can multiply the 7s together, that's 49. Remember, square root of 2 times square root of 2 is 2. So 49 times 2, and so that's 2x squared equals 98. We want to get the x squared by itself, so let's divide each side by 2. And so we get x squared is 49. Take the square root of both sides, and you get x is 7. And so this is actually an important result about squares. If you have the length of a side of a square, then the diagonal will have that number times the square root of 2 as its diagonal length. All right, so we're going to go ahead and stop right there. If you have any questions, let me know.